So let's start with problem number 77. For his trip to London, Matteo changed 200 euros into 147 pounds. Pounds is the British currency. He looked on the internet for the prices of 3 items of clothing he wanted to buy. So he got price in Paris for a jacket is 140 euros. The same jacket in London is 100 pounds. Similarly with the jeans, 90 euros, 65 pounds, 40 euros and 30 pounds for the sweater. What clothes should he rather buy in London? Now a number of you didn't quite understand this question. The question, what it meant is that which of these 3 items are cheaper in London? He's going to London, so should he buy these items in Paris or should he buy them in London? Now the thing is they're mentioned in different currencies, but we know the conversion rate. What is the conversion rate? We can see that he changed 200 euros into 147 pounds. So let's solve this problem. So we have 200 euros gets him 147 pounds. So 200 euros is equal to 147 pounds. Therefore 1 euro is equal to 147 divided by 200 pounds. Divide both sides by 200. This is what you get. Which if this I do in the calculator, I get 1 euro is equal to 0.735 pounds. Okay. Now I've rewritten the table there. Ignore the numbers in red. This is just a table which was there. I've just copied it. Now what I'm going to do is I'm going to use this conversion factor. This is a linear function where the price in euros is equal to 0.735 into the price in pounds. So if 1 euro is equal to 0.735 pounds, then 140 euros is equal to 0.735 into 140 is equal to 103 pounds. Okay. So we use this conversion factor or this linear function to get that 140, if the x is the price, if you want me to write, I'll write here as a function, though it should not be necessary. F the x est égal à 0,735 x, où f the x is price in euros and x is price, I'm not even focusing there, in pounds. So this is the function f de x est égal à 0,735 x, où f the x is price in euros, x is price in pounds. So you just have to replace this with the price in pounds to calculate the price in euros. So that's what we do. For 140 euros we will get is equal to 103 pounds. This is the f the x. So 140 euros is the price of the jacket in Paris, which is equivalent to 103 pounds. So we can write here 103 pounds. That is what 140 euros is equal to. Similarly, we take the 90 euros, we multiply it by 0.735 and we get 66 euros. These numbers are rounded up, rounded up, rounded down. They're not exactly 66 but almost 66. So I can write there 66 pounds. Similarly, because this is 40 euros is equal to 29 pounds. So now Matteo can compare. The jacket costs 103 pounds or equivalent of 103 pounds in Paris, but only 100 pounds in London. So the jacket he should buy in London. It is cheaper in London. The jeans are 66 pounds in Paris, 90 euros, but that's equivalent to 66 pounds. In London, they're 65 pounds. So, again, the jeans are cheaper in London. The sweater is 40 euros in Paris, which is equal to 29 pounds here. So, I write it here in red. And in London, it's 30 pounds. So, the sweater is cheaper in Paris. The jeans and jacket are cheaper in London, which leads us to the answer to this problem. Jacket and jeans are cheaper in London, and Matteo should actually buy these two items in London. Sweater he should buy in Paris. Now we come to this problem, number 78. Représenter une situation. Louise court à la vitesse de 15 km/h. Now this I will not do because all of you who did it correctly. One of you didn't do it at all. But it's a very simple problem. Okay. So now we come to the one that confused almost all of you. That is this La Piscine de Marius. Okay. So here what we have to see is we're really not concerned with the volume of the pool. We are only interested in the height of the water in it when it is being filled, and how to turn that into a function in terms of the hours while it is being filled. So if it is filled with for 2 hours, what is the height of the water in the pool? If it is filled for 1 hour, what is the height? If it is filled for 3 hours, what is the height? To calculate that, we need to find the function. So here the last line is aidez Marius à trouver une formule, which is une fonction ici, donnant la hauteur d'eau 1 cm en fonction de la durée de remplissage. That means how long the pump has been running. So let's solve this, and I've done this here. So here we go. This is the pool, and really we aren't concerned with the height of the pool as such, which was 1.8 meters. We are only concerned with the height, as we say, h. So what is the volume of water in the pool when the height of water is h? So then we can calculate its volume is longer, larger for hauteur. So longer is 8 mètres, larger is 2.5 mètres, and hauteur is h. We don't know what exactly it is, but it is h. So, but this h is in centimeters, so we divide it by 100 to get it meters. This is in meters, 2.5 is in meters, 8 is in meters. So this comes to, if you multiply 8 into 2.5, 20, 20 divided by 100 into h, which is V est égal à 0,2 h, où V is in meter cube and h is in centimeters. This is very simple. So if we say the height of water is 100 centimeters, then the volume of water would be 0.2 into 100, that is 20. The volume would be 20 meter cube. Okay. So this is as far as the volume of the pool goes. Remember, we are not using the actual height of the pool, which is 1.8 meters, because that is really not relevant to our problem. Okay. Then we come the filling rate. This is the pumping rate. The pumping rate is 25 liters per minute. Okay, this is given. Il utilise une pompe qui a un débit. Débit means throughput or rate of 25 liters per minute, 25 litres per minute. So let's turn it into liters per hour, because we are interested in hours. So it will be 25 into 60 liters per hour. 1 minute has 1 hour has 60 minutes, so just multiply it into 60. So you get 1500 liters per hour. But remember, here we don't have it in liters, we have it in meter cube. So we have to convert this into meter cube. So 1 meter cube is equal to 1000 liters. So this is equal to 1.5 meter cubes per hour. So the filling rate of this pump, which is 25 liters per minute, is the same as saying 1.5 meter cube per hour. Okay, so now we have to, what will be the volume after T hours, what will be the volume of water in the pool? Well, that is very simple. You just multiply this into T and you will get that volume of water. So V is equal to 1.5 into T, that squiggle is supposed to indicate multiplication, into T meter cubes, because you take this and multiply it by the number of hours, you will get the volume. So this where T is in hours and V is in meter cube. Correct. We also know now we are going to link the height to the volume and to the filling time. So we know V is equal to 0.2 h. So here we say we also know that V is equal to 0.2 h, and therefore 1.5 into T, 1.5 into T is equal to 0.2 h. This is V and this is also V. So now from here we get, I just flip it around, I write here 0.2 h into 1.5 T, and then I divide both sides by 0.2, so I get h is equal to 1.5 divided by 0.2 into T. 1.5 divided by 0.2 is actually 7.5. So the answer is h is equal to 7.5 into T. This is the final answer. H is in centimeters, T is in hours. None of you got this right. One of you came close, but you had T in minutes. You forgot to convert it into hours. So suppose I say that if I'm running the pump for 2 hours, what will be the height of the pool here? What will be the height of the water? Not height of the pool, height of the water in the pool. So we know here h is equal to 7.5 into T multiplied by 2, 15. 15 what? 15 in centimeters. So after 2 hours of running the pump, I will have 15 centimeters of water in the pool. This is the answer that we were looking for. It has nothing to do with, you can if you like find out how much time it will take to fill the whole pool, because the height is 1.8 meters, but that was not a question that was asked in the problem. Okay? Now we come to the last of these 4 problems. 81, démontrer des propriétés. This is actually very simple. Quite a few of you got it right, but you made a mishmash and total jalebi of writing the answers. So here, this is the way you should do it. We'll start from the top. F de x est égal à 1,5x, because they've said on note f la fonction linéaire de coefficient 1,5. So this is f de x est égal à 1,5x. Very simple. Then they say calculate f of 5 plus f of 2, that is equal to 1.5 into 5 plus 1.5 into 2 is equal to 7.5 plus 3 is equal to 10.5. No problem there. Then they say calculate also f of 7. F of 7 is simpler. 1.5 into 7 is 10.5. So say what can you see? You can see that this is equal to this. So therefore f of 5 plus f of 2 is equal to f of 7. Then they say démontrer que pour tous nombres x et x prime, this equality is valid. So here is where you have to do a little bit of côté gauche, côté droite. So here you say to show, I write it in English, to show that f of x plus f of x prime is equal to f of x plus x prime. So let's take côté gauche. côté gauche is this. I just copy it, f de x plus f de x prime, and then we develop it. Est égal à 1,5x. We know this, f de x est égal à 1,5x, and this is 1,5 x prime. We factorize, we can write 1,5 x plus x prime. Okay. Excuse me switching from English to French and back. Okay. Now côté droite, we take this. Côté droite, f of x plus x prime is equal to 1,5 for x plus x prime. But we see that we already have that there. So already we have shown that CD est égal à CG. So we see CG est égal à CD. Donc, f de x plus f de x prime est égal à f de x plus x prime. So we have proven it. That's it. That's all we had to do. Now we'll do the same thing with the part 2, which uses, instead of the plus, it uses multiplication. Here first of all again they say calculate 3 for f de 4, that is 3 into 1.5 f de 4 c'est 1,5 fois 4, 3 into 1.5 into 4 is 18. Similarly, the second one, f de 3 fois 4, so this is 1,5 fois 3 fois 4 is 1,5 fois 12, 3 into 4 is 12, is equal to 18. Again, so we can see, therefore 3 fois f de 4 est égal à f de 3 fois 4. And finally they ask us to show this for any x. So k fois f de x est égal à f de k fois x. To show this, again we'll take côté gauche, k fois f de x est égal à k fois 1,5x est égal à 1,5 fois k fois x. I just put 1.5 to the front. Okay. Côté droite is k fois fonction f de k fois x est égal à 1,5 fois k fois x est égal à 1,5 fois k fois x. K fois x fois 1,5. So again you see these two are equal. We see CG est égal à CD, donc k fois f de x, est égal à f de k fois x, So this is the way you have to solve this. That is, you shouldn't do it any other way. You should, whenever you are asked to show that something like this is equal to something like this, you take this one on the côté gauche, you come to an answer, you take that and you come to the same answer. Here this answer is equal to this answer, and then you can say, we see that this is equal to this, therefore this is equal to this. That is what you wanted to prove, and that is what you have proven. Okay, so these are the three problems. A lot of you had problems solving them, and this is the way you have to solve them. If you like, rewind, watch slowly, pause, and make sure you understand, so that similar problems you can do later on your own.